Waves, waves, and waves. In our last video, we looked at wave and we made a calculation on progressive wave. I'm sure you're good with that. If you have any question as regards that, remember you're always very free to send in your questions. I will just do justice to that. Alright, in our last video, we also looked at what is a wave. We said a wave is a disturbance that travels through a medium and transfers energy from one point to the other without what? Causing any permanent displacement of the medium itself. I remember we gave a general classification for wave, a very broad one. We said our wave can be divided into two broad classes. One, whether a material medium is needed for propagation or not. There we had mechanical and electromagnetic wave. Two, based on the direction of the travel of the wave to the direction of propagation of the particle. That gave us longitudinal and transverse wave. Isn't that true? Now, but what we're going to do in our video today is look at some terminologies used in waves. Terminologies such as amplitude, terminologies such as wavelength, frequency, period, and of course, our wave speed. I'm sure you've seen a wave drawn. This distance, the height covered by the travel of the wave, is my amplitude. The maximum displacement of a wave from its equilibrium position. Look at, the wave is displaced to this height. So from the equilibrium position, that's from this zero mark, the maximum displacement of a wave from its equilibrium position is my amplitude. Wavelength. Of course, our wavelength is depicted by the lambda. So where you see your wavelength, look at the lambda. And this is measured in meters. What is the wavelength? Now, wavelength, I'm going to define this in two ways. Wavelength can be defined in terms of transverse waves or in terms of what? Your longitudinal wave. Please look at this. Take notes. This is my transverse wave. It has what? Crests and troughs. This is my longitudinal wave. Look at this. You see, there are regions where the wavefront is very close. We call that rarefaction. We call that a compression. Now, there are regions where the wavefront is far away from each other. We call that what? Rarefaction. So, for a longitudinal wave, we have compression and rarefaction. For a transverse wave, we have crests and what? And troughs. Now, so if I want to define my wavelength, the wavelength can be defined as the distance between successive crests and troughs. That's for a transverse wave, right? The wavelength can also be defined as the distance between what? Successive compressions and rarefactions. I hope you got that. Beautiful. Frequency. Frequency talks about occurrence. So if I want to define frequency based on my wave, is the number of complete oscillations or cycles performed by a wave in 1 second. The number of complete oscillations, look at that, frequency. The number of complete oscillations or cycles performed by a wave in 1 second, that is what? My frequency. Please take note that frequency, symbol F, measured in hertz. Take note, measured in hertz. I'm coming to give you the formulas. Period. Period. That is just the time taken for a wave to make one complete oscillation. That's period. I take that again. I said the period with a capital T is the time taken for a wave to make one complete oscillation or cycle. You see that my period is related to frequency. Yes, I think they are brothers and sisters. I think this one is the nephew or something like that. I hope you got that. Okay, so we have finally the wave speed. Wave speed. Now, my wave speed with a V, just like speed. You remember speed? You remember speed? Distance over time. The total distance traveled by a wave in 1 second or per time. That's speed. Now remember, they will always tell you this when you get to grade 10. What's the difference between speed and velocity? They have the same unit, meter per second. So meter per second. So what is the difference between them? Remember that speed is a scalar quantity, while velocity is a vector quantity. Meaning that speed has only magnitude, no direction, while velocity has both what? Magnitude and direction. And remember, speed is distance over time, while velocity is displacement over time. I hope you got that. Now, look at these formulas so that you just go ahead and keep solving. Go ahead and keep solving. Take note, my wave speed is a product of frequency and wavelength. Equation 1. That means, of course, my frequency will be wave speed over lambda. I can also make lambda the subject of formula. That will be what? Wave speed over frequency. Let's call that equation 3. Are we together? Now remember that frequency is inverse of period. Let's call that equation 4. Also, period will be inverse of what? Frequency. Let's call that equation what? 5. I trust you got that. Now look at this. I told you something about frequency that is measured in what? Hertz. But there is a new unit. You can actually calculate frequency in terms of period. And what is the unit of period? Seconds. So tell me, what do you think will be the unit of frequency, if not hertz, in terms of period? I want your answer in the comment section. If you know the answer to that, just send it to me on the comment section and I have a gift for you. I don't want frequency measured in hertz. What other units can we measure frequency in? I'll see you in the next video.